This is Populations and Resources, Lesson 1.4. You should have just completed Lesson 1.4 warm-up, and then you're going to watch this video before you do Lesson 1.4 Activity 2. So in this lesson, you guys are acting as student ecologists, and you are trying to figure out to determine why the moon jelly population in Glacier Sea increased in size. So this is our unit phenomenon. This is the whole point of this unit, is to figure out why the size of the moon jelly population in Glacier Sea has increased dramatically. So in the last lesson, you saw me using tokens to model how births and deaths in a population can cause a population to increase, decrease, or stay the same. So the ecologist from Glacier Sea Research Center told us that the moon jelly population increased in size. So how does she know this? It would not be possible to count all the moon jellies in an entire population. So how do ecologists actually know if a population is increasing or decreasing in size? So in a moment, we're going to watch a short video to learn about how ecologists collect evidence about population changes. While you're watching this video, I want you to be thinking about how do ecologists get evidence about populations. So while we're watching this video, we're trying to figure out how do they gather evidence about populations.
Today we're at the Louisiana University Marine Consortium, which is the main center for marine science research in Louisiana. So if we want to understand whether jellyfish populations are increasing or decreasing, it would not be a very effective method for me to sit here and watch the jellyfish float by counting them one by one. What we really need to do is go out into the ecosystem, and to do that we need to get on a boat. So today we're going to use the RV Acadiana and go out and try a couple different collection methods that are much more efficient. Alright, here we go. We got Captain Carl on the RV Acadiana. All right, you ready to go? All right, let's get out of here. One of the ways that we can collect jellyfish is just directly, which is using a dip net. The way that we do this is we just take a large net that you would use for fishing, and we have a spotter, and they just look for jellyfish that are close to the surface of the water. Oh, I see one! Oh, I got it! All right, I'm gonna track it. Got it! All right, I need a bucket. So after we finish dip netting them, sometimes we'll take them out of the bucket and we'll measure them. And after we finish with it, we take the jellyfish and we put it back in the ocean. There you go. So this dip netting method is really great for helping us answer questions that are about individual organisms, but it's not effective for answering questions that are about the population. So we use a technique called trawling to collect jellies from many different places. The technique of trawling has multiple steps. The first step is we throw out the cod in, which is the back of the net, and the net gets fed out of the back of the boat. So then we tow the net for a set period, and then we haul the net in. Perfect. Way to go, Carl. This is exactly what we want to look at. Okay. So we got some fish here, and we have looks like 4 or 5 moon jellies that we caught here in the trawl. We can use repeated sampling to estimate the number of jellies that are in our ecosystem. We go around to different places around our ecosystem and we put a trawl in, and then we bring the trawl up and we count the number of jellyfish that are in that trawl. And so then we repeat this method multiple times. We then can generate an average estimate of the number of jellyfish that are in our ecosystem. Trawling is a technique that allows us to capture the number and the distribution of jellyfish in an instant. But if we want to understand how the jelly populations are changing in time, whether they're increasing or decreasing, we need to sample them repeatedly over time. So for example, where you can go out 1 month, let's say January, and we sample a set of sites, and then we'll go out February, and then we'll go out in March. And then by taking repeated samplings, we can then understand how their numbers are changing through the year. And what this allows us to do is develop a time series that then can tell us whether jellyfish in the ecosystem are increasing or decreasing. So these time series that I'm talking about with repeatedly sampled jellyfish are actually very, very important to understanding long-term changes in not only jellyfish populations, but all ecosystem parameters, including fish, crabs, shrimp, everything that we care about. But these time series are really hard to collect. Scientists need help from the citizens, but also we just need more scientists, because the more people that we have monitoring our oceans, the more information we'll have and the closer and more quickly we can get to answers.